Now we will discuss when to forget. So see, basically in agentic AI systems, forgetting is not a bug. Rather, it is a design decision. Forgetting is a design decision. So in a world of infinite data, it is tempting to think an AI should remember everything, but that is not possible because of the limited context window, and also in agentic AI architecture, unfiltered memory is a liability. Effective orchestration, it requires a selective filter to keep the AI focused, accurate, and economical. Because we know that the context window is limited, we cannot store everything in it. And if you are making use of the long term memory, also, we have to selectively filter only the relevant chunks into the active context window. So effective orchestration requires a selective filter to keep the AI focused, accurate, and economical, because the context window can hold only fixed number of tokens, and API pricing is based on the token counts. So the accuracy will also depend on the tokens which are present in the context window. So the idea is very clear that in the context window, we cannot store everything. We have to store only the things which are very important, which we want the large language model to focus on. We want that large language model should focus on these things. Only those things we should put in the context window, because whatever is there in the context window, that will be fed to the large language model, and large language model will process all those things. So let us discuss the necessity of forgetting. Why forgetting is necessary in agentic AI systems. So one very important reason for that is the context window limits. We know that the context window size is limited. Every LLM has a buffer size, the tokens which it can hold. So if we fill that context window with irrelevant data like hello, how are you, there is no room left for complex data needed to solve the current problem. So the idea is very clear that the context window is limited, the buffer size is limited, it can store only a fixed number of tokens. And if we fill the context window with irrelevant data like hello, how are you, or something which makes no sense, then we are basically like there will be no room left for complex data needed to solve the current problem, and hence here it makes sense to forget. So here it's very clear that we should forget unnecessary words or irrelevant words like hello, how are you. We should forget it. We should not at all add that in the context window. So now it is making sense that why we should forget, why forgetting is important, the necessity of forgetting, because the context window size is limited, and irrelevant words we have to forget. Instead of adding it in the context window, we should forget it so that we can make room for complex data which will help in solving the current problem. Noise reduction. So if an agent is helping you write code and you briefly mention your lunch, that lunch data becomes noise. Like let us suppose you are in a conversation with an agent AI system, you're discussing about the weather, and all of a sudden you're giving it the lunch data, then that lunch data will become noise because that lunch data has nothing to do with the weather chat. Similarly, if the model tries to find patterns in that noise, it may hallucinate or lose track of the coding logic. So now the idea is very clear that here we have to forget the lunch data. So the idea is that like when we are using an agentic AI system, the user all of a sudden in the middle, he may give some unnecessary prompts or some unnecessary data. No point of storing that data in the context window. We should forget that to avoid hallucination. Just imagine if we are considering those data points as well, we're trying to find patterns in that noise, because we know that lunch data has nothing to do with the coding problem or the weather chat you are having with the agentic AI system. So lunch data is like, let us suppose all of a sudden the user is giving a prompt, did you had lunch? Like in the middle, like if the user starts asking the large language model, did you had lunch? Now that data is irrelevant. No point of storing that message in the active context window. So that's the idea. So noise, we have to forget it. Noise reduction. Otherwise, it will just hallucinate the large language model. So irrelevant information is noise, and that irrelevant information we should forget. Cost efficiency. See, large language model providers charge by the token. The LLM providers, they charge by the token. Processing 50 pages of chat history for every single yes or no response is financially unsustainable. J- Just imagine, like, for a single yes or no response, if I give it a 50 pages chat history, then I am just unnecessarily wasting the money. Financially, it will be unsustainable. So that's why I have to forget. So the idea is very clear that large language model, they charge based on the tokens. So no point of keeping everything in the context window or even storing it in the long term memory, because that will be an unnecessary liability. So we have to forget noise, irrelevant data, so that we can get rid of unnecessary tokens and save money, save dollars. So processing excessive history for simple replies can be very expensive, and we should avoid that. Now the next very important point, like why we should forget, is the relevance. See, the idea is that old information can become stale. Let us suppose if you change your mind about a flight destination, the agent must forget the old one to avoid booking the wrong ticket. Like let us suppose you are deciding about a flight destination. So first you decided about the Paris, but later on you changed your mind. And once you changed your mind, it is always good to forget the old info, because the old information, it can become stale. So after a point of time, old information, if that old information is replaced with something new, we have to forget the old information, and it will avoid unnecessary mistakes or hallucinations. Relevance. So now it's very clear to us the necessity of forgetting, because the context window is limited. We cannot store everything in the context window. So we should avoid storing irrelevant information, the noise, the old data, and with that, we are also reducing the unnecessary tokens and saving dollars in terms of cost efficiency. Now let us discuss the mechanics of smart forgetting. The mechanics of smart forgetting. So developers, they use several techniques to decide what stays and what goes. So the first technique of smart forgetting is the sliding window. So the system only sees the last n messages, and as new messages comes in, old ones fall off the back. So that is the concept of sliding window. System only sees the last n messages, and whenever new messages come in, old ones will they will get out of the sliding window. So sliding window is one of the mechanics of smart forgetting, is one of the way to achieve smart forgetting, wherein old messages we can flush it out from the sliding window. Now, the second technique for smart forgetting is summarization. So, summarization is like memory compression. So, the idea is that instead of remembering a 10-step argument, it's always good to compress it into a single sentence. So, that is what is summarization is about. So, instead of just storing the 10-step argument detail, we should compress it and then store it. For example, the user and agent agreed on a $500 budget. So just one sentence, I replaced it with a 10-step argument details. So here, details forgotten, memory kept, meaning kept. So summarization means the crux of it. Like just imagine 10-step argument details I have. I am just taking the crux of out of it, the meaning out of it, and just storing it. So I am forgetting all the details, just the meaning I am keeping it. So that is the summarization. And in this way also, I am forgetting unnecessary information, unnecessary details I am forgetting. So that's a technique of smart forgetting. Now, one more very interesting technique of smart forgetting is vector pruning. Vector pruning. So in long-term memory, like vector databases, the system only retrieves facts that are mathematically similar to the current task, effectively forgetting the rest of the database for that specific moment. And that is what is vector pruning is. So in vector database, there is a concept of semantic search. So the idea is that the vector database, it is like a long-term memory. It holds everything. Let us suppose it remembers everything. But we will retrieve only mathematically similar facts. So based on the user query or the prompt, we will retrieve only the mathematically similar facts, forgetting the rest of the database for that moment. And in this way, we are just focusing on what is important. We are not flooding the context window with unnecessary information. Rather, we are putting only the relevant tokens in it, and we are forgetting the rest of the database for that moment. And in this way, we are achieving smart forgetting. So vector pruning is a very effective technique of smart forgetting. Now we will discuss the selective memory framework. Selective memory framework. So the goal is to maintain a high signal to noise ratio. Like we want more signal and less noise. So we want to keep the active brain very clean. So that's the main goal. The context window, we have to populate the context window with clean tokens, and we have to get rid of the noise. So we will discuss the selective memory framework to achieve that. So for transient data, so that for like if we are dealing with transient data, we should forget it there itself. We should forget the transient data there itself. For example, syntax errors that were fixed. Syntax errors that were fixed, we should get rid of it. Polite filler or temporary search results, we should get rid of it, because temporary search results, no point of storing it in the context window. Syntax errors that already got fixed, no point of it storing in the context window. So the idea is very clear. The transient data, we should forget it there itself. If we talk about completed task we should archive in the long-term storage. Completed task we should archive in the long-term storage. For example, once a cancel order task is confirmed, the step-by-step logs of that process are no longer needed in the active brain. Because once a task got completed, now we don't want that in the active memory, active brain, the short-term memory, the context window. We don't want completed task in the context window. Rather, we should archive it in the long-term storage. to make room in the context window. If we talk about user preferences are very important. We have to protect it. We have to keep it in the context window. We have to keep it in the active brain. For example, like I am allergic to peanuts or I prefer Python over Java. So these are some examples of user preferences. They strictly have to be in the context window because every response of the large language model should consider these user preferences. User preferences are very important and they have to be the part of the active brain always. Permanently, they should be. And similarly, active state. Active state, like let us suppose in a multi-step task, the response or the outcomes of the steps should be the part of the active brain, the context window. So the active state and user preferences, we have to store it in the context window. For example, we are currently on step 3 of 5. Losing this causes the agent to loop or stall. So now it's very clear to us that, okay, transient data, we should forget it. We should just wipe it off. Completed task, there is no need to hold the completed task information in the active window. Rather, we should archive it to some long-term storage. If we talk about user preferences and active state, we should protect it. We should keep it in the active brain. We have to keep it in the active brain, the context window. They are very important. Memory as triage. So we should think of agents memory like a doctor's office. So let us think the agent's memory as doctor's office. So the idea is that the clipboard is the active state. So the doctor is maintaining a clipboard. So when the doctor is diagnosing a patient, the active state, he will note it down in the clipboard. So clipboard is the active state, like what is happening right now. The patient file is the long-term memory. So what is true about this person generally? So the patient file is the long-term memory. And the waiting room, and in the waiting room, the chit chat, that is the noise. The chit chat in the noise, the chit chat, the chatter, there is a noise in the waiting room. Like what did the patient say about the weather while walking in? We should forget it immediately. So now it's very clear that if we talk about agentic AI system, whatever is happening right now, like like agentic AI system is in action, it is solving some problem, it is doing some kind of an orchestration. So the active state, we have to store it in the memory. We have to store it in the context window. So what is happening right now is very important for us. We have to store it in the context window. And the long-term memory, like the patient file, the information about the patient or the task which are completed, the information of it, that is also important for us, that we can store it in the long-term memory so that we can refer it whenever we want in the long run. So the patient file is acting like a long-term memory. But the noise, we should immediately put it in the trash. Now let us discuss a core insight about when to forget. A perfect memory creates an agent that is easily distracted and expensive. A perfect memory, if we talk about, it creates an agent that is easily distracted and expensive. Because if I talk about a perfect memory is one which tries to remember everything. A perfect memory is one which also considers the noise, which tries to remember everything, which tries to store everything in the long-term memory as well as in the short-term memory. And hence, since it is trying to remember everything, it will lead to easy distraction and it can be very expensive also because irrelevant tokens, we are storing it in the context window, we are processing it, and we are paying extra charges for the API because LLM providers they are billing based on the tokens, number of tokens. So a perfect memory creates an agent that is easily distracted and expensive. And a selective memory creates an agent that is sharp, fast, and personalized. So now it's very clear that we should forget. Forgetting is very important. We don't want a perfect memory, rather, we want a selective memory because with selective memory, we will be avoiding unnecessary noise and hence it will be sharp, fast, and personalized. So, good intelligence is defined as much by what it ignores as by what it attends to. So, when we talk about good intelligence, what agent AI system ignores is also important as what it attends to. So ignoring is also very important. So in agentic AI system, if we talk about in terms of the memory systems, there is like forgetting is very important. It agentic AI system should not remember everything. It should forget the noise. It should forget the irrelevant tokens. It should ignore it. And that's the core insight.